Okay, I'm back, and now we want to talk about what are the things that influence how a terrestrial planet is going to eventually look. And so I want you to think about dominoes, that if you have a whole bunch of dominoes set up and then one of the dominoes falls over, it then hits the other domino next to it, which hits the domino next to it, and then it just continues like that. Well, this picture kind of shows how when one thing changes, it changes another thing, which changes another thing, which changes another thing, just like a whole bunch of dominoes. So here we've got the factors that influence the terrestrial planets, and there's basically three. So the primary control knobs that are going to control the fate of a terrestrial planet is going to be what was the initial mass of that planet, what was the distance that that planet was from the sun, and then did that planet have a large moon. So let's look at the first one. Okay, the mass of a planet influences its gravity. So the larger a planet is, the more gravity it's going to have. Okay, now what difference does that make? So a planet that has a large amount of gravity is going to be able to hold on to a thicker atmosphere. So the less gravity a planet has, the thinner the atmosphere is going to be. Okay, the next thing that the mass affects is the heat retention. So imagine that you've got two potatoes. One is a little potato and one is a big potato. So you can do this experiment, put both potatoes into your oven and cook them until they're both at the same temperature. And then take out the little potato and the big potato, put them on the counter, and just leave them there. And then every 5 minutes, touch them and see what happens. And you should notice that the little potato is going to cool off faster than what the big potato is. So a little planet is going to cool off faster than what a big planet is going to. So this is going to explain, for example, the moon versus the Earth. So the moon is much, much smaller than what the Earth is. So the moon cooled off faster than what the Earth did. So what difference does that make? Okay, two things. One is heat causes plate tectonics. So in our previous lesson, we learned that the heat of the inside of the Earth is making the mantle, mesosphere part of the Earth convect, and then that in turn is what drives plate tectonics. So if you've got a small planet that has cooled off rapidly, it no longer has that heat on the inside to be able to drive plate tectonics. And then the other thing is that the hotter a planet is on the inside, the more of a magnetic field it's going to have, because we talked about that the origin of the Earth's magnetic field was in the outer core, and it was that liquid iron and nickel going around and around in the outer core that generated our magnetic field. So if you've got a small planet, its magnetic field is going to be greatly diminished, or it might go away completely. Now what difference does that make? Remember, it's dominoes here. So the plate tectonics is going to be associated with volcanism, volcanoes, and volcanoes are going to be what's going to produce the atmosphere. And then also we're going to find that the magnetic field of a planet helps to protect it against the solar wind coming off of the sun. So the debris that comes off the sun, we call that the solar wind. It's a real wind, and it can actually strip the atmosphere off of a planet if there's no magnetic field. So if a planet has a magnetic field, that's going to act like a shield to keep that solar wind from eroding the atmosphere off of that planet. Okay, so what difference does that make? So now we talked about how heat retention causes plate tectonics, which causes an atmosphere. So what does the atmosphere do? Well, one, an atmosphere helps to erode the surface of a planet. So especially here on Earth, where you've got clouds composed of water, and then when it rains, the rains can erode the surface of the planet. Okay, another thing is a thick atmosphere will act as a meteor shield. So basically anything that is smaller than a refrigerator does not make it through our atmosphere. So by the time that an asteroid that is the size of a refrigerator travels through our atmosphere, it has burned up completely. So you need a larger asteroid than the size of a refrigerator in order to make it to the Earth's surface. Okay, the atmosphere also helps to hold water down. It keeps water in its liquid form. So as you reduce the pressure of an atmosphere, it makes it easier for water to boil. And so like on Mars, for example, Mars no longer has liquid oceans, but in the past we think it did. And those liquid oceans evaporated because the atmosphere of Mars got too thin. So we'll talk about that later. And then the thicker the atmosphere, the greater the temperature is going to be on that planet. So the surface temperature on a planet is going to be greater the thicker the atmosphere is. And now let's look at water. So what does water do? Okay, water can get in with the rocks on an ocean floor so that those rocks are saturated with water, and then that's going to make that lithosphere easier to melt and easier to bend. And that's going to be important when we talk about the plate tectonics on Venus. So we'll come back to this. Also, liquid water moderates the climate. So think about what's the climate like in Hawaii and what's the climate like in North Dakota. So in one case, you've got a place that's surrounded by water, and in another place you got there's no water. And you notice that the swings in temperature are greater in North Dakota. It's colder in the winter, it's warmer in the summer than what it is in Hawaii. And it comes down to that Hawaii is surrounded by water. So water helps to moderate the climate of a planet. And then we found that the oceans absorb carbon dioxide and turns it into limestone. So we'll talk more about that later. And then some of the other arrows on there. So the more carbon dioxide in the atmosphere, the hotter the planet is going to be. And we're going to call that the greenhouse effect. And then the distance from the sun, okay? So the closer you are to the sun, the greater the solar wind is going to be, the more powerful it's going to be. And then that means that it's more of a chance that the atmosphere will be blown off. And then obviously, the closer you are to the sun, the hotter it's going to be. So that's going to affect the climate of the planet. And then finally, you've got this presence of a large moon. So that's going to act as a stabilizer. So whenever you've been at the circus and you looked at somebody walking the tightrope, okay, how do they walk the tightrope? Do they put their arms down like this and then they're walking on the wire? Or do they have their arms out like this? Or do they have like a 10-foot pole that they're carrying? So what difference does it make? So whenever you take your arms and you put them out at your sides, that gives you more balance. It means you're less likely to tip over. And the idea of carrying the pole is it goes out further than what your arms can, and it's got more weight. So that combination makes it harder for somebody to tip over when they're on the tightrope. Well, that's what our moon does. So our moon is like a gigantic pole that extends into space away from the Earth, and then that keeps the Earth from wobbling. So the Earth is at like a 23-degree angle, and it is precessing, so it's doing this over 26,000 years, but in general, it does wobble a little bit. It wobbles through the course of millions of years by about 5 degrees. So 5 degrees less than 23 and 5 degrees greater than 23 degrees. But if the Earth had not had a moon, then the wobble of the Earth could go anywhere from 0 to 90. And so think about what would the climate be like if the Earth spun straight up and down. Well, that would actually not be so bad. We wouldn't have any seasons. It would be cold at the North Pole, it would be hot at the equator, and we would have the same temperatures all year round. Now we're tipped at a 23, which means that we have summer, winter, fall, and spring. So we have the seasons. But if it was tilted like this, then that would mean that for part of the year, we would be getting direct sunlight, and so this part of the Earth would be completely lit up and would be very, very hot. And then for the rest of the year, so when it orbits to the other side of the sun, then that part of the Earth would be in complete darkness. And so the seasons would be very severe, and you can imagine what effect that would have on life. Okay, we're going to take a break now, and when we come back, we are going to talk about why does water boil.